So we want to solve problem 3.42 from Sadiku book. So the question is find I1, I2 and I3, and I1, I2 and I3 is loop current here using mesh analysis. Okay, we have these three loops, but here we have current source here that we cannot know the voltage, so I'm gonna do super loop analysis. So here we have very large loop here, and let's name this super loop. Okay, the blue one is super loop. And now let's start analysis at this loop I1. Loop I1, and we apply KVL. The sum of voltage in a loop will equal 0. And we will start from this voltage source, and the current is flowing from negative to positive, so the sign will be negative. And the value is 12, so I will have minus 12. And we move on to this V0. I mean this resistance, it's 2 ohm, so we add 2 here, and we focus on I1. So here I1 here, but here I2 is flowing to the opposite direction, so I subtract I2 from it. And then we move on to this last resistor, this 4 ohm. Again we multiply it by I1, but here I3 is flowing to the opposite direction, so I subtract I3 from it, and all of this will equal to 0. Not enough space, so I will equal it here. So here we do some algebra to simplify this. This I1 here, 2I1 plus 4I1 become 6I1. And here we have I2 minus 2I2, and we have minus 4I3, and we move this minus 12 here, so it's become 12. And let's save this as equation number 1. Okay, we have our first equations, and let's do the super loop analysis. So at super loop, again we are using KVL, which is the sum of voltage is equal to 0. If we are doing super loop analysis, we don't look at this super loop current, but each individual current that it contains in it. So here we start from this 2 ohm resistor. We start from that 2 ohm resistor. So here we have the focus of it is I2, so I multiply it with I2. But here I1 is flowing to the opposite direction, so I subtract I1 from it. Then we move on to this 8 ohm resistance, plus 8. The only current that passes through it is I2 here, and we are not going to do analysis on this current source because we look at this super loop. And now we move on to this voltage source. It is flowing from positive to negative, so the sign will be positive, and the value of it is 2V0. And now we move on to this plus components here, the 4 ohm resistance, so 4, and here the focus of it is I3, and I1 is flowing to the opposite direction here, and all of this will equal to 0. Now we do some algebraic manipulation. 2I2 plus 8I2, and okay, 2i2 plus 8i2, that will be 10i2. For I1, I have minus 2 and minus 2 plus minus 4. Oh, sorry. Here minus 2 and minus 4. So I will have minus 6i1. And then for I3, I will have plus 4i3. And for V0, the only V0 left is that, and it will equal to 0. And how about V0? What can we do about it? Okay, the V0 is by Ohm's law. We can calculate V0 here. Okay, so if we look at V0, it is the resultant factor of I1 minus I2, or vice versa, times 2 ohm. So here we can plug this into this. So I will have 10 I2 minus 6 I1 plus 4 I3 plus 2 times 2 is 4, and here we multiply I1 minus I2 here, that will equal to 0. And what can we do here? We do some algebra again. For I1, I have minus 6 plus 4, which is minus 2 I1. And for I2, I have 10 minus 4, which is plus 6. And for I3, I have only 4i3. And that will equal to 0. And let's save this as equation number 2. Now we have 2 equations, but we have 3 variables here. 1, 2, 3. So we need one more variables. So if we look at this node, let's say this node as node A. Okay, we have node A. We can apply KCL at node A. Here, the current that goes in node A is equal to the current that goes out. Okay, we have this current that goes in is this 3 ampere and this I2 here. Here, it's the same as this loop. And the current that goes out is here. It's the same as this loop 3. So we have the current that goes in is 3 plus I2, and the current that goes out is I3. So we can do algebraic manipulation again. So I have I2 minus I3 is equal to minus 3. And let's have this as equation number 3. Now we have 3 equations and 3 variables. First, let's erase this board and rewrite the equations, and we will solve that. Okay, so we have cleaned the board, and let's see what can we do about this system of equations. Okay, I see this minus 4 and 4, so I can eliminate I3 from there. And let's see, 1 plus 2. So I will have this one, 6 plus minus 2, it's 4 for I1. And here, minus 2 plus 6I2, it's plus I2. Plus 4I2. and this will cancel each other, and it will equal to 12. Or we can say that I1 plus I2 is 3. And let's save this as equation number 4. And now again we are going to eliminate I3, but we are looking at this case here. Equation number 1 plus equation number 3, but multiplied by 4. Okay, equation number 1, we have, okay, I will copy it for make things easier to see. Minus 4I3 that will equal to 12, and this one is 4I2 minus 4I3 that will equal to minus 12. And here we subtract this value, so I will have 6 minus 0, that will be 6I1, and then minus 2 minus 4, it's minus 6I2, and here we will have this cancel each other, and this one will equal to 24. Or we can say that I1 minus I2 is 4. Let's have this as equation number 5, and we have this nice equation of equation 4 and 5, so we can do right away that 4 plus 5, we will have I1 plus I1, 2I1, and then we will have 3 plus 4, it's 7, so I will have I1 will be, so I1 will be 7 divided by 2, it's 3.5 ampere, and thus we can easily get I2, because I1 plus I2 is 3, so I2 will be minus 0.5 ampere. Okay, we have I1 and I2. Now we can get I3 from there. We have I2 is negative 0.5 minus I3 is equal to minus 3, so I3 will be 3 minus 0.5, so we will have I3 is equal to 2.5 ampere. So I will have I1 and I2 is this, and I3 is this, and hopefully I did not make any mistakes in the calculation. So we solved this, and thank you for watching.